Hi everyone. So this is the last part of percentages. So in this we will look after the final value or the final percentage and compound increase or decrease of percentage. It can be both increases, both decreases, or an increase and a decrease. Okay, so let us calculate a basic value. If 80 is increased by 40%, find the final value. Okay, let's say if 80 is increased by 40%, how do you calculate? What is the final value? Final value is 80 plus 40% of 80, right? What we do is basically we calculate 40% of 80 and add to the 80. That becomes our final value. So 40% of 80. So if I calculate, this will be 4 multiplied by 8, which is 32. The final value is going to be 80 plus 32, which is 112. So most of us know this already. If they ask, let's say 80 is decreased by 30%. So we calculate 30% of 80 and subtract from 80, right? So similarly, for any variables, let's say x is increased by 20%. So what will be the final value? X plus 20% of x. What is 20% of x? 20% of x. So 2 upon 10 in decimals, I would like to write it as 0.2x. One decimal, x plus 0.2x. These are similar terms with coefficients 1 and 0.2. So this will add up to 1.2x. Similarly, you can pause and try and solve the other two ones. Now, y is decreased by 10%. So the final value is going to be y minus 10% of y. Okay, again, if you calculate 10% of y, which is 1 upon 10y or 0.1y. Which is 0.9y. Okay, here a is increased by 150%. So the final value is a plus 150% of a. So if I calculate 150% of a, 15 upon 10 is 1.5a. So I'm writing all in the decimal values and not fractions. Sorry, this is a. So a plus 1.5a, again similar terms, this is 2.5a. So this is how we calculate the final values. Okay, this is a bit on the higher level side. If population increases by 10%, then the new population is 110% of original population. For example, what we have seen, let's say if x is increased by 20%, so the final value become 1.2x. Now what is 1.2? This is decimal. If I have to convert in percentages, I need to multiply by 100. So 1.2x is 120% of x, right? So what is happening if you understand or if you observe keenly, if value is increasing by 20%, final value becomes 120% of that value. That's exactly what they are saying. If population increases by 10%, the same way, right? Y decreased by 10%. So final value became 0.9y in the previous slide. Okay. What is 0.9y? Convert decimal to percentage. 0.9 multiplied by 100 is 90. Okay, 90% of y. Decreased by 10%, so final value is 100 minus 10, 90%. It's good to remember this. If someone is comfortable, it becomes quite easy. Let's say if A increases by 50%, what is the final value? Final value 100 plus 50, 150% of A. Now, if you want to convert percent to decimal, you just divide by 100, right? Or you just put two decimals, 1.5. So this is how we can solve the percentages, okay, directly. So you can go through the other things. 30% increase, so 100 plus 30, 130, and 15% decrease, 100 minus 15, so 85%. Now, similarly, successive changes. So let's say if there's a value 100, it's increased by 20% and let's say decreased by 10%. What is the final value? So if 100 is increased by 20%, 20% of 100, which is 20, right? Most of us know. So this becomes 120. Now 120 is decreased by 10%. So we have seen the standard percentages. 10% of any number is one decimal. So 10% of 120 is 12. Or you can calculate. So you subtract 12 from 120. What you get is 108. So this is called successive percent change. There is an increase and a decrease. Similarly, we can calculate this for any variables also. Now, let's say if I say that x is increased initially by 30% and further increased by, let's say, 20%. Find the final value in terms of x. Okay, two ways to look at it. You can solve x plus 30% of x, or you can say 130% of x. Either way you're comfortable, you can solve. So both ways you will get 1.3x. Okay. Now here it is important to note that this is entire one value, 1.3x. Okay, this 1.3x is increasing by 20%. It's not x which is increasing by 20. It's this entire 1.3x. Okay. Now we have seen if some value is increasing by 20%, it becomes 120% of that value, right? So the decimal equivalent of this is 1.2 of that value. So final value is going to be 1.2 times of 1.3x. Now, if you're not comfortable with this, calculate 20% of 1.3x, which is 20% of 1.3x, which is 0.2 of 1.3x, and you add them, right? The final value is 1.3x plus 0.2 times of 1.3x. So I can take this 1.3x common. I get 1 plus 0.2, which is 1.2. Either ways, you will get the same answer. So I hope the concept of final percent or final value is clear. We'll solve 2-3 questions. A particular stock is valued at $200 per share. Okay, so let's say this is the original value, $200. If the volume is increased, or if, sorry, this has to be value. The value is increased by 25%. Okay, and then decrease by 10%. What is the final value of this stock? So 25% of 200. So which is 50. So the first value after 25% increase is going to be 200 plus 50, which is 250. And then decrease, okay, arrow below, decrease by 10%. So we know what is 10% of any number, one decimal. So the final value is going to be 250 minus 25. 10% of this is 25. So we will get the value as 225. Like I said, those standard percentages, 10% and 1% will help us in a lot of calculations. Okay. So I hope this is clear. This is that consecutive or successive percent changes. Now, One more question. A football team has won 20 games out of 30 played. Okay. So let's say played and won. Played 30 and won 20. So lost, let's say, is 10. This is what I understand. So I'm just writing it. It must play 26 more games. So 30 played, 26 more to come. How many of the remaining games, how many of this 26 must the team win to make its record to 75%? Okay, win record to 75%. So let the number of matches that the team has to win is X. Okay. So total games that they're going to play is 56. And they want to win percent to be 75% of the total games played. Okay. I hope this is clear. How many of the remaining games must the team win to make its record to 75%? So 75% is 75 upon 100 of 56. Can cancel in 25 table and 4 table. 3 multiplied by 14. This will give us 42. So the team has to win a total of 42 games. Okay. So x plus 20 is 42. X has to be 22. So 22 out of 26 games the team has to win to achieve 75%, to achieve 42 winning game. So that will be option A. Okay, one last question. A 60% discount reduces the price of a mobile by $300. So this is important. Now, what does this mean? You'll have to think a bit. This is saying, let's say if you go to a store to buy some laptop, okay, and then the store seller says there's a 10% discount. And if you avail this 10% discount on some credit card, your price will decrease by 10,000. Let's say dollars. I mean, it's not possible. That laptop is so costly. Let's say 10% discount will reduce the price by $100. So what does he mean? He means that 10% of the laptop price is equal to $100, right? That's what he means. 10% discount will decrease the price by $100. That means 10% of the total price is equivalent to $100. Similarly, 60% discount reduces the price by $300. So what does that mean? Is 60% of the total price, the total laptop price is $300. So let the laptop price be X. We can find the value of X. 60% of X is 300. So X will be 300 into 10 divided by 6. So goes 50. So X, the total price is $500. If the discount would have been 20%, so out of 500, let's say if the discount is 20%, what would be the selling price? Okay, so what we'll do, we'll calculate 20% of 500, which is 20 upon 100 multiplied by 500, which is $100. So the final price would have been 500 minus 100, which is 400. Or you can directly calculate, because there's a 20% decrease, 80% of 500, you'll get the same, $400. So this is how you will need to calculate the final value or final percent or successive changes in percentages. I hope this concept is clear. I'll see you guys in the next session. Thank you.